All right, welcome everybody. Thanks for coming. I can see if I can kick things off a little early. I have a lot of slides to go through. But before I dive into this talk, I wanted to kind of give a quick background of like why this talk. I sat through a bunch of awesome talks yesterday around AI agents. It's what everybody's talking about. But oftentimes they're talking about like the outcomes of those agents, and that's awesome. And so when I was putting this talk together, I was like, let's just open it all up, right? It's the whole point of the title, not so secret agents. So I work at Red Canary. It's an MDR company out of the US. I lead our data science there. And I've had the pleasure of building AI agents now for well over a year. We have AI agents in production. I was just checking the stats this morning. We do about 350,000 agent calls a day. Some of our agents have done upwards of 1 million investigations. And so the content of this presentation, although it's focused in on a very specific use case, all of the sort of failures, successes, lessons learned are really wrapped up in a lot of the things in here. So I really hope that y'all take it all in. And at the end of this, I'm open sourcing all of the code to build all of this. The whole point is that this community, this awesome security community, should go on and build great things. There's nothing secret about this. So let's dive in. Just really quickly, like I said, I lead our data science practice at Red Canary. I've worked in cybersecurity my whole career. I started off working for the US government, doing offensive and defensive things. Went into the startup world, worked at Carbon Black for a long time, helping them make their endpoint agents. And now I'm at Red Canary. My passion is in blue teaming, although red teaming is fun. I think it's really hard to do cybersecurity at scale. As you can imagine, at Red Canary, we have thousands of customers to protect, and making sure that we have the highest quality product, catching the threats when we should be, is up to us the utmost importance, and that's my team's focus and mission. So here's our agenda. Super quick, don't worry about really diving into this, but before we talk about the so what of building agents, I thought it's important to just level set. There's a lot of marketing and hype around these agents, and I want to just make sure we're all on the same page and demystifying some of that. And then I sort of have this super simple 4-step recipe that we all follow internally on how to scope tasking for agents, and then ultimately, no kidding, we'll go through prompts, contextual engineering techniques, all that good stuff, and show you how to build all of that. And then we're going to orchestrate it. So it's one thing to build these sort of bespoke individual agents. That's actually the whole point of building a robust agent architecture. But how do you bring them all together in a durable execution framework? And we'll introduce this open source library that we use called LangGraph. And then we'll demo it. I was going to be brave and do it live, but then after sitting through talks yesterday, I was like, let me do a video. And so I have a video in here, and you'll see the full agent in action. You're going to see each one interacting. You're going to see all the data of its investigation streaming live. And it really helps show why going from like really in your IDE writing code to like a graphical interface and debugging is really helpful when a team of people is trying to build these agents at a velocity to deliver, enterprise software. And then, it's one thing to build these agents and look at how cool it is and see tokens streaming across the screen, but it's another thing to actually quantify them and say, hey, are these paying off? Is it worth the value? Are they causing more work than we're trying to automate, right? And so I'm just introducing a super simple technique that we use internally, to measure the accuracy of these things. And then we'll have a conclusion. And if I can get through this stuff fast enough, we'll do some Q&A. So let's dive right in. So here's our quick agent intro. What are agents? And at Red Canary, we think a lot about the jobs to be done in a SOC. And so this is just a definition that I put together, but I think that agents in the SOC are AI systems that can think and act like an analyst using reasoning and tools to autonomously achieve complex security goals. That is it, right? We're here to use AI to automate tasks. We're not here to take jobs. Automating tasks is key because it allows the humans to work on higher level work, right? And so what you see here are the jobs to be done in a SOC. Of course, it's not all inclusive. This is just a high-level summary. But when I was putting these slides together, this old analogy of sometimes when you have a hammer, everything looks like a nail, right? That is AI today. Everyone wants to put AI everywhere. And I'm here to tell you, don't do that. Pick the right reasons to use AI. And so you should still use classic automation in your SOC where it's appropriate. There's no need to overcomplicate it, to slow it down, to make it cost more money. But there are dozens and dozens of places in the SOC where you can use AI to augment the busy work. And so in this talk specifically, we are going to zoom in to the forensics collection and analysis. I wanted to have a super concrete example with real data that y'all can leave here today and go start working with and building agents. And so forensics collection and analysis is something that it's a time-consuming process. There's lots of data to chug through and to create these reports. And so why don't we build some agents and do that, right? So that's the whole point. So before we dive into that, I wanted to sort of define the different agent operating models. Not all agents are created equal, and it's very nuanced in how you use these agents to do tasks. So let's level set. So how many people in the audience, quick show of hands, has used a Copilot in one of your security tools? That's awesome. It's actually, I was not expecting that many hands. And so Copilots came about. They're actually really useful. A ton of high-level human control. That's one of the key things in the SOC, right, is we need predictability and determinism. Copilots are useful when you're an expert. And what do I mean by that? If you're going to do a task with a Copilot and you already really understand that task really well, I'm going to bet that you're going to have great success in using that Copilot. But if you don't fully understand that task and you just start asking this thing questions, it's going to go haywire, and I guarantee you're going to have a bad experience with that Copilot. And that's sort of, in today's world of where these Copilots are implemented, I think is the sort of downfall, and they're going to have to get smarter and sort of automate some of those upfront tasks where people might not be an expert. And that's what leads to the sort of next agent mode. I call it the interceptor. And this agent mode is a high-speed filter. So an example would be an identity alert comes in. An agent takes that alert, and it goes off and pulls a bunch of data and does some anomaly detection, does some enrichment, and builds this super nice report for a SOC analyst to look at so that you're not manually doing that, right? The great part about these interceptor agents is there's a high level of human control and determinism. That is super important in the SOC, right? Accuracy and predictability is the number one thing you need in the SOC. They are not, quote unquote, agentic. They don't have tons of agency to go off and do things. They're following a deterministic step 1 through 10 path, right? And so, spoiler, we're going to be building an interceptor today in this talk and walking through that. And then finally, agent mode 3, this is full-on Terminator, right? This is where you give the AI a task and it magically goes and figures out everything, right? So the example goal would be investigate this phishing alert and contain the threat. Well, to do that, there is a lot of complicated back-end things that are happening. Again, you're giving the agent a ton of agency and trusting that that agent is going to go off and create the right to-do list and pick the right tools to call and go bring that all together, and hopefully it runs. And these are probabilistic in nature, meaning they're random, right? These LLMs are probabilistic. So if I ask the AI, hey, go investigate this phishing alert 10 times, it'll do it 8 times, but the 2 other times, who knows where it ends up, right? And that's a problem in a SOC when you need that deterministic tasking, right? So we've level set, we've understood these 3 agent types, and so we'll sort of dive in now on like the automation styles themselves. I put this table together because I think it's really important. I'm not dismissing fully agentic AI at all, but what I'm saying is you need to choose the right tool for the right job. And so this Towards Data Science blog that I found, we found that about a year ago, and I was like, oh my God, whoever wrote this like read my mind, because this is exactly how we approached it at Red Canary. But how defined is the problem you're trying to solve? Is it open-ended or poorly understood? Or are the steps and goals clearly defined? How should the AI think? Should it adapt to everything that's coming in, or does it follow a predictable path? What is the human's role? Are we delegating the trust to the AI, or do we want to provide direct oversight as a human? And so forth. But the key thing here is repeatable tasks. So in this talk, we are going to talk about a structured workflow. So we're going to build an agentic structured workflow where we're going to build 8 different agents that are all orchestrated together and provide these sort of forensics reports for you to analyze from an endpoint. So before we dive into the nerdy things, I want to talk about an overall strategy, right? Like any good software engineer, you need a design doc, you need a spec, you need the higher level architecture. So I want to set the stage of how we're going to build this. And a quick show of hands in the audience, how many people have used OSQuery? Not as much as the agents, but after this talk, it'll be everybody with their hands up. So OSQuery was actually made by Meta way back in the day. And think of it this way. It overlays a SQL interface on like all of the operating system innards of your computer. And it can run on Mac OS, Windows, Unix, you name it. It runs on BSD. So when I was doing this research, there's 280 different tables. And you can see in this screenshot, this is a query, and in the source code that's there on GitHub, you'll get the query for it. But essentially, I'm joining the users and groups tables together, and you get this nice JSON structure of the users, groups, UIDs, GIDs, everything. But what does that look like? As a human, we're not good at parsing this stuff. You know who's really good at parsing this stuff? The robots are, right? And so if we have a mountain of data in this forensics collection, we want to train the robots to interpret all of that and do it in a very deterministic way. And so when I was building this talk, I said, what is the bare minimum needed to do forensics analysis on an endpoint? So there was 39 different tables, essentially. I'm focusing on Windows here. And so across 39 different tables, I need to pull all of that data together and tell an accurate story. I need to do it fast. And so what's great about this OSQuery project, there's tons of documentation. All the specs are freely available, and we can use it to help coach the AI into being the most accurate that it can. So we're going to take all of that to our advantage. So this is a super simple illustration, like a horsey ducky diagram, as I like to call it. So pretend Jimmy's sitting at that laptop, and I have a server that I want to run forensics analysis on remotely. So I'm going to use my EDR agent, and I'm going to live response into that server, and I'm going to push the OSQuery I binary on that machine. I'm going to push my script down to that machine. I'm going to run my script that's got all my queries in it. It's going to output all of that in JSON for me. It's going to put it in a folder. It's going to zip it all up. And then I'm going to use that live response agent to pull that zip file back to my laptop. And then I'm going to extract that laptop. And now I have a directory full of all of this JSON that I have to make sense out of and make a forensics report. That's what we're going to build the AI agent to do, to focus on chugging through all of that data and giving you that output. So here's a mermaid diagram that I put together. Think of this as like your spec, right? This is where you start off, where you have this agent to table mappings. So you have our artifacts and file system analysis. We have our process and security analysis. We have our network analysis, and we have our systems and hardware analysis. Those are like the big buckets that we want to focus in on forensics-wise, right? And getting a good report. So with each one of these buckets, sort of grouping these together, you see these little small boxes. Each one of those little small purple boxes is the actual table in OSQuery that we're querying that has the corresponding JSON that goes with it. And so, for example, you have a software and artifacts agent, and that agent is only focused on working on that one narrow task, software and artifacts. Then you have a file system agent, you have a users and groups agent, and so forth and so on. The key thing to take away here is not the problem we're trying to solve, it's that you need to keep your agents narrow and focused. If you don't do that, that's where they start to go off the rails. That's where they hallucinate. That's where you'll have runaway costs, and they'll be really slow. So you want to keep everything narrow and scoped, and the magic is when you put them all together and working in unison is where you get those great outcomes. So what's the recipe of this? We're going to build, like any good sort of cookbook, right? You need this 4-step recipe to bring things together. It's not super complicated, but this is the fun, nerdy stuff that I love. We'll dive in on just like, how does this happen? How does the rubber meet the road in building these agents? And so you have ingredients, right? When you like any good recipe, and you need to define that goal, right? And by having that mermaid diagram and building all of the sort of separate processes for these agents, it helps you define the goals to a very narrow scope. So what is that task that the agent's going to do? It's going to be a forensics driver analysis, a users and groups analysis, a software analysis. That's the task. You need to have an objective, right? Again, a narrow objective. You're going to suss out all of the suspect user accounts, or you're going to enumerate all the user accounts and put them in a report. And then the outcome, like what is the ultimate outcome of all of this? Those are the key things that before you write any code, before you go prompt any AI, like you need to have this written down in a document somewhere. That's the key part. And the fun thing is you can likely take that natural language and copy and paste it into your prompts, right? That's the best part about this technology. Preparing the data, this is a single most important step. As a data science nerd and fellow ones in the audience, 80% of my job, 90% of my job is being a data janitor, right? Querying the right data, gathering the right data, compressing the right data, cleaning it, enriching it. That is the biggest thing. And so we like to say garbage in, garbage out. It's the same with the AI. You don't want to give it too much information for the task you're asking it to do, because that's how it can go off the rails, right? So we're going to select the right OSQuery tables. We're going to pre-process all of that for clarity. We're going to inject all of the README files and documentation for that so that the AI knows exactly what it's analyzing. And this is a phase where you can do enrichment, right? You can call VT, you can go enrich IP addresses, enrich domains, get ASN numbers, all those sort of things, and bringing that all together. The more context, the better it's going to be for the AI, because it's not going to try to make things up. Output. Many folks maybe not know this, but most large language models nowadays are fine-tuned to output in JSON format. And you might think, why does that matter? When you have a multi-agent system working together, you need to guarantee a contract of that software, right? It's no different than classical software engineering, where I have this contract, so my software outputs this schema, and whatever systems interact with it know to expect that exact schema. And the same with agents. You can tell it literally through natural language, output in JSON format, and output this schema. And you put the literal JSON schema in there, and then these AI models are fine-tuned to abide by that. And that is a critical step. And you'll see when we do the demo, you'll see the JSON, you're going to see all the data and how the AI does that. One note here is, you can do in the prompting, you can say, hey, this is the JSON schema to follow, and it will do it. And then like newer OpenAI models, they actually will allow you to define the schema in your call. And so you can do it in both places. I say this because early on with these models, it would output JSON and it would be incorrect and it would break things. And you're like, oh, what the heck, my AI is breaking stuff. A lot of the newer models have fixed that. They get better and better over time. And we have things like JSON repair functions in our software stack to do that. But this is sort of like the most important piece here is that JSON output can then be used for follow-on systems. So that's part one, the ingredients. Part two is the method. So how do we actually bring those instructions and those architectures to life, right? And so for an agent, I love to do this. You have to anthropomorphize the AI, right? You have to give it a role. You're the world's best forensics investigator. You're the world's best chef. You're the world's best workout assistant, whatever, right? Like you give it that so that it assumes that role and it makes it much more accurate in its responses. One of the tricks to sort of agent engineering is this concept of tools. Most these commercial foundational providers, you can do tool calling. And this is where you can say, for example, I have a virus total tool. And while the agent's doing its work, it can go out and call the virus total tool to enrich hashes, IP address, domains, et cetera. And then you want to force the agent to think. And so we're going to use this concept called chain of thought prompting. It sounds super complicated. It's super simple. All it is essentially in your instructions to the agent, you're saying, step one, do this. Step two, do this. Step three, and so forth. That is a chain of thought. And so when you prompt the AI and it's doing its processing, it will do its best to follow those steps. And when we in a further slide where we're talking about LLMs, some of these LLMs are much more stubborn in following directions than others. And it's something that we like to joke about on the team. And then finally, like I said, selecting your LLM. And I have a slide that follows this up that will go in more detail. But really what you want to make sure is how fast are these models? How smart are they? And how much does it cost me? Those are the big things. There's lots of great open source models that are out there, but they're not very good at general knowledge in cybersecurity. And so I still believe that you can use a lot of these commercial closed source models. They're super cheap, they're really fast, and they're excellently knowledgeable at generally everything in cybersecurity. And we've seen that at Red Canary in our use of them. All right, so we've got the recipe, the method. Let's talk a little bit about LLMs. I call it the engine room, right? But the so what here, the key principle is start with a good enough model. GPT-4o is the workhorse of LLMs. That is super fast. It is really cheap, but like I said, it's stubborn. It's no matter how many times you tell it to do a certain thing, sometimes it just doesn't listen. But that's where we usually start off with all of our experimentations. And because it's good enough and fast enough, it has good enough knowledge, general knowledge in it, it's the perfect model to experiment with and build these tools. I would highly recommend starting there. Our default model internally for all of our agents today is GPT 4.1. It's definitely a good upgrade over 4.0. It's a little bit slower, it's a little bit more expensive, but it's less stubborn and it follows directions a lot better. It's a lot better at tool calling. It's a lot better at the JSON output and listening to the schemas and things like that. Sonnet 4 is something we use extensively internally for coding. It is excellent at coding. It's excellent at problem solving with like engineering tasks. And then, the king, GPT-5, recently came out. We are experimenting with it everywhere internally. It is fantastic. Yesterday, the National Institute of Standards and Technology NIST, came out with a study that I thought was fascinating. I think it's the first most extensive measurement of an LLM. They tested an LLM across almost 700 cybersecurity tasks. And they tested several different models. And GPT-5 blew all the other models away in terms of general knowledge and its abilities across the board in cybersecurity. And I think that's a really good sign that as these new models come out, they're getting smarter and smarter and smarter, which tells me the models we're using today are the worst models we'll ever use in the history of AI engineering, right? But it's really expensive. But as you know, with all technologies, things get faster and cheaper over time. And I fully expect a GPT-5o to come out that's cheaper, faster, et cetera. But yeah, the reason why it's so good is the reasoning. And you'll actually see I have some data in here that shows you, wow, it is pretty good, but it's also really slow and expensive. All right, so here's some of the so what. Let's go inside the agent's mind and this concept of context engineering. Context engineering is like a hybrid of prompt engineering and software engineering put together. And here's an illustrative example where here's like the so what of what's in these agents. And like I said, this code, you'll be able to scan a QR code. You'll have all the source code. Literally everything will be in here. Go have fun with it. Do what you want with it. But this is what I'm showing you here. See, it says role. You're an expert cybersecurity forensics analyst specializing in OSQuery-based investigations. That is it. That is demystifying some of this magic, right? You have to just give it super simple instructions and you keep it simple. Task, analyze the provided OSQuery data, Windows installed drivers, using the defined OSQuery schema sections and context, and follow those, strictly follow those instructions. And your objective, produce a concise and actionable forensic summary according to the output format guidelines, right? That's that JSON schema, highlighting suspicious activities, potential threats, et cetera, et cetera. The user prompt, right? This is where the context engineer, you're going to say, Jimmy, that's not like language, that's a function. Create user prompt. Yes, that's part of the magic here. When you're running this at scale, when you're doing this dynamically, you're going to want to inject the right things at the right time. And that's some of the software engineering practices in here. And so in this specific case, I'm injecting the date and time. I want to know, since we're doing forensics analysis, like when the heck was this run? And the AI should know when it was run, right? I'm injecting the raw JSON contents that are serialized from those OSQuery queries, right? And I'm giving it the exact SQL command that I ran. And I'm also giving it the manual. Hey, for this SQL table, here's what every row means. Here's what every type means. Here's what description of every single piece of data that you're going to analyze. Again, to minimize hallucinations and to increase accuracy. Here's your chain of thought prompting, right? Where it says forensics instructions. Identify unauthorized and malicious drivers. Step 1. Oh yeah, I remember that, right? Device and ID name. Review the device ID in columns and identify unfamiliar or unexpected devices. I'm not going to go through all of this, but you can see that each step is clearly thought out. It makes it really easy for a human for debugging things, and it's also super important for the AI when it's following instructions. And then the structured output contract, right? You can see here it's literally that easy. You must output JSON in the following schema. JSON, boom, key values, that's it, right? So that's how the AI is going to know how to output in a specific format. And when we do the demo, you'll actually see all of that coming to life. And so if you're not familiar with like system prompts and user prompts, I know I kind of dove right into that. If you've used ChatGPT, which I'm sure all of you have, when you open a new chat and you start typing into that, that's the actual user prompt. You can't at ChatGPT, you can't adjust the system prompt. Folks have dumped the system prompt. You can see what's inside of there, but it's very specific for the tasks, the general tasks that ChatGPT would use. The power in using these APIs and building your own custom agents is you can adjust that system prompt for the AI to assume whatever role it wants, right? So that's the super important catch here. All right, here's the fun stuff. Let's orchestrate and evaluate and see where the rubber meets the road, right? So what you see here is a picture of the agents. And this isn't anything magical that I did. I get this for free by using LangGraph, again, which is an open source product. But you can see here we have preparing the input data. Oh yeah, Jimmy talked about that. That's how we have to do data preparation and cleaning. And then you see all of those 8 agents. But you see them orchestrated in an interesting way, right? And this is called fan out, fan in workflows. And by using this simple LangGraph library, I can parallelize API calls to an AI, right? Because each one of the agents doesn't depend on the other one, I can call them all in parallel, right? And so going from 10 minutes to a couple seconds, I can get all of these agents to run at the same time, and then I can aggregate all of that data. But this is the magic of LangGraph. What it allows you to do is build these graphs. It uses DAGs for folks that are in the data engineering world. It builds these DAGs and you compile these graphs, and it guarantees that your workflows are going to follow these nodes and edges and execution points. But you can do things like, hey, after this node executes, force a human in the loop check. Hey, after this node executes, go run an LLM as a judge. After this one, run in a few loops. And this graph framework is actually the one enforcing all of that. And the durability and the predictability of this is actually what makes it super powerful, right? A lot of folks think the LLM is what makes these agents magical. I personally think, and going into 2026, what everybody will be talking about are your agent backends. What is the tools you're using to orchestrate all of this stuff? Because that's how you're going to scale this stuff and get multiple people on your teams building these tools and incorporating them together. The other part of it too is it allows the sort of routing of things. So you can route specific tasks to specific agents, and that's sort of the magic of all of this, right? Is we spent all of this time building and fine-tuning all of these prompts, explaining all this information, but if we just blast it all out in one LLM call, like that's where bad things happen. That is not what you want to do. You want to keep things narrow. You want to keep the data narrow. When you start introducing all of the external data that an AI doesn't need, that's when you get the hallucinations and you get poor accuracy in your results. All right, let's run through this. So before I dive in, really quickly, you're going to see that graph. You're going to see me paste in the folder name where all of that JSON is, and then I'm going to hit go, and we're going to walk through. You're going to see things lighting up. You're going to see the agent running. You're going to see stuff scrolling on the screen. So let's see. So this is LangGraph Studio. Again, this is that visualization of the agents, and you can see you can click on each one. I can interrupt. I can make breakpoints. I can see the source and targets of the graph that's already been compiled and where it's going to run. So here's my directory of all of my forensics data that I want to analyze. So I'm going to hit submit. And this is where all the calls happen. So you can see all those agents are now running in parallel. You can see the JSON for each one of them starting to stream and see how they're starting to fade into the background. That means it's complete. But I didn't have to write any code to do that, right? The LangGraph library is doing that for me. And so once that's done, all right, now it's doing the aggregated results. So now it's taking the results from all of that. And you can see stuff scrolling through the screen, absence of BitLocker, all of these high priority IOCs with weird binaries and temporary directories. You can see all this sort of detailed findings of hardware drivers from Broadcom and NVIDIA. You can see that there's outdated versions of Java and Firefox, right? So it just finished the aggregated results, and now it's taking that and creating 3 separate reports. It's creating a quick look report. It's creating an executive report, and it's creating an IOC report that I can feed to my tip that's in JSON format. And so here I am now just sort of scrolling through. What if I want to debug this? I want to look at the data that came in. Look, here's every single serialized JSON. I can scroll through it. And I can say, oh, maybe it didn't grab the right system info. Oh, no, it says it's an Eng workstation with the CPU and RAM. Perfect. Let me go look at the agent that analyzed that. Here's that JSON format, right? Here's the forensics analysis stage. You can see it's an Optiplex tower with 32 gigs of RAM. You can see the uptime. It says that BitLocker is not on there. It has a medium risk level. I'm going to go look at the WMI events, right? Everyone's favorite place to hide for persistence in Windows. And look, based on the WMI events, it found a bunch of really suspicious event consumers and persistence mechanisms and credential harvesters. You can see if I go into the aggregated results now, you can see the executive summary, right? You can see all of the different things. You can see that it found privileged account misuse, malicious processes, WMI-based credential harvesting, several different things. So in real time, I can just really easily go through this. I can see exactly where I am in the agent workflow and what I'm trying to debug and what I'm trying to inspect, right? But what else do we have here? OpenRDP, enabled VPN tunneling and adapters. You can see the attack sequence of what happened because the boot time was 7 days and there were WMI persistence. The AI was like, hey, this must have been here a while, right? So it's pretty neat to see it. You see all the artifacts of the WMI events that are in there. It's really helpful to just bring it all together. And so then I'll go into the reports, right? Because this is really what matters. The output of this isn't this aggregated report. It's actually those 3 sub-reports. Because as an analyst, when I bring all of that data together, I actually want to see what's going on. I need that 60-second look, right? So boom, event level, critical. Workstation is actively compromised in a confirmed attacker persistence. You can see that there's high risk issues, low risk issues, medium risk issues. It's telling me the immediate actions to take. Again, this is all from the prompts that I'd given the AI. I want it to go in this specific format. And here's my IOC report. So not only can I do it in Markdown, but I can do it in JSON, right? And so you see it was able to pull all the IOCs out with their severity, with the sources that they came from, with the specific IOCs that we care. And so I hope this helps you sort of demystify and visualize, right, how these AI agents work, how they all come together, and how it's easy to debug. And this is where the power comes in of letting your teams see this stuff, load up the graph, go through, debug things. Again, so it's one thing to build this, to see the fruits of your labor in AI engineering, but none of it matters if it costs too much, it takes too long, it's not accurate, and it's not consistent, right? The single biggest thing that I have found in building agents at scale is building the trust of your customers, right? In this case, it's our security operations engineers at Red Canary. If I lose their trust that the AI thing that they're building isn't accurate, that's it. You have like one chance. And so when you build these tools, you can't just build it and set it on the shelf and be gone. There's a lot of care and feeding to AI agents. So if you're going to build these, know that there's an investment to be made in keeping the speed, the accuracy, the consistency, and cost in line. But I'm being generous here. I'm saying, looking at that mountain of JSON of 39 JSON files, I'm giving a human 30 minutes to look all through that. I would guess if you're doing that at 2 in the morning and there's an incident going on, it's probably not going to be the best quality, right? But I'm thinking, with an AI agent, can I do that in under 2 minutes? That's the goal that I've set out. You need some sort of business justification to say, I'm going to build this to improve my efficiencies. Accuracy. If the agent is creating more work than the work it's trying to do, that is not good, right? You gotta go back to the drawing board. How repeatable is it? Can I do this over and over again in a durable way and ensure that I'm getting the same results? And then finally, cost. If we're gonna go broke doing this, then it's not worth doing it. If I don't have the capacity to call these cloud providers, then I can't do it. So you gotta take all that into account. So because this is a black hat talk, let's go into some of the data. Here's some speed and time measurements. So I ran this AI agent workflow with all of these 4 models and instrumented all of it. Actually, in the source code, there's a cost tracking script that you can run, and it will output all of this for you. But like I said, I started with GPT-4o. And look at that. Our goal was 2 minutes. It ran this whole workflow in 36 seconds, almost 37 seconds, and it did it for 34 cents. You can see the tokens per second. That's a really important measurement of looking for AI agents. It's 3,600 tokens per second. That's really fast. So, and the output number, which is the number of tokens, which is essentially the text that you see in those reports or in the JSON, is around 6,000 tokens. That's where the cost comes from, most of the cost comes from as well. So, all right, GPT-4o exceeded our expectations. Let's go to 4.1. 90 seconds, 36 cents. That's totally cool with me. Again, because it listens to directions better, because the output is more reliable, and you can even see here in the output token count that it's more verbose. I like that. You can see the tokens per second is still pretty darn good. Sonnet 4, like I said, is a great model. It's doing it in under a minute for 39 cents. Again, totally acceptable, but look at how small the output tokens are. I found that Sonnet, the family models of Anthropic, they're very terse. It's like, here's your response. And you like that for some things, especially when you're writing code. But when you're doing more human interaction stuff, it seems, at least my qualitative assessment from OpenAI, is their models seem to be a little bit more verbose, explain a little bit more. The older models like GPT-4 like to blab on and on sometimes, and you're like, okay, that's robot cruff. But overall, Sonnet did good. And now everyone's looking at GPT-5 and they're like, 17 minutes? What the heck? Yeah, so to be fair, I ran this with medium reasoning. GPT-5 can do reasoning built right in as a flag when you call it. And the other thing that I don't recommend you do, but because we're trying to compare apples to apples, I ran the same model across every one of those nodes. You wouldn't want to do that in production. In the actual individual agent layer, those 8 different agents, you'd probably want to run a cheaper model like GPT-4o, because all it's doing is chugging through data and outputting JSON. That's really good for that stuff. But in that aggregate node, where we're aggregating all of those together, I totally want to use GPT-5 and its excellent reasoning and smarts to build a much better report. And then maybe those follow-on agents that are building those reports, maybe those I can use like a GPT-4.1 to just make sure I'm getting a good final output. The thing to note here and why the cost is a lot higher, look at the output tokens compared to everything else. This is significant. And again, that's because it's sitting there, it's reasoning, and the reasoning tokens count against your total token count, and it's also much more verbose. And you never want to be in this avoid zone, right? And that's why I gave you these specific models. These are the ones to start with. But I'm honestly super bullish on seeing how GPT-5 really up-levels everybody's security capabilities across the board. So let's talk about building trust with that consistent output and accuracy. This is sort of some of the harder parts in AI engineering, right? So we have the core forensics analysis, that's those 8 agents. And then we have that aggregated report, right, which has that exec summary, key findings, yada, yada, yada. But the ultimate product that these agents are building are those 3 reports at the end, right? It was that 60-second briefing, that executive report for leadership if you need it, and that threat intel report for your tip, right? And so because we're using a durable execution framework like LangGraph to execute all of this, I can guarantee that no matter how many times I run this agent framework or this agent graph, it is always going to execute and produce those reports because I have control over the system prompt, I have control over how I want those reports to look, and so no matter what time of day, no matter how fatigued a human is running this, it's not going to matter. You're going to have the same high quality reports that come out every single time, right? So success, and that's because we're using a framework like LangGraph to do that. And finally, and this one will be a little bit of hand-wavy due to time, but how do we validate that the actual data that the AI agents are producing is accurate? Well, we actually like to, internally, we do this in production. We use semantic similarity algorithms. And what the heck does that mean? Well, we have a controlled data set. And so think of the data set in this open source project that you'll be able to access as the control. And so when I run the AI agent and I get like that 60-second report, I can use a semantic similarity algorithm to take a signature of that essentially, right? And then let's say I go and I adjust the agent instructions, or I change the model completely from underneath it. And then I go run that again, and I take that same 60-second report and I take a similarity signature of it and I compare the two. What semantic similarity allows you to do is say, hey, is this 80% or more similar? If it is, I'm cool with it. If it's less than 80% similar, I want a human to look at that. And you might say, well, you're just allowing the AI to just, output tokens and a human's not reviewing it. No, that's not what I'm saying. A human has reviewed that sort of gold master similarity piece, right? We use this in our CI pipelines at Red Canary. And we know that this is the output that a human's reviewed and what we want. And so anytime we update things, if that test fails, we'll go in. That doesn't necessarily mean the output was bad, especially when you're doing model upgrades. It might be less than 80% similar, but when you read it, you're like, actually, that's better than the original one. And that just means you got to go in and update your test case to say this is the new gold master, and then frequent tests and things will come through. So that is one key area where you can measure the similarity of the agent output through scientific method and make sure that it's always the same. Accuracy. This one where you might be like, this is that Spider-Man pointing meme, right? LLM is a judge. If you haven't heard of that term, it's an industry accepted term. And so what we're actually doing, and we do this in production, is we know that 60-second report should always have a title that says severity. It should always mention a specific host name. It should always mention specific user accounts, right? And so what we actually do is we take an LLM, that's another agent, that's specifically designed to check the output of that agent, and we're going to use JSON mode, and we're going to say test, true, fail, key values, whatever you want, and we're going to run an LLM as a judge, and the LLM is going to decide, hey, did the output of this match what I needed to look at, right? It works fairly well. On these ones, we use more powerful models because we want them to reason, we want them to be the most accurate, but this is a really good way of assessing the accuracy and the output of an LLM. And finally, how could we not mention Yara at a security conference? Yara is one of my favorite tools, but what it's really good at, if you've never used Yara before, it is the Swiss Army knife of building signatures, right? And so what Yara allows you to do in a really simple syntax is say, count words, count the amount of periods, count the amount of commas, count how many times the word Jimmy is mentioned in the output, right? And so I can build Yara signatures for very normal things like, hey, if I want a super simple summary, this should never be over 700 characters, I can write a Yara signature to scan the output of that, and when it's over 700 characters, it's gonna fail, right? And so those ones are much more brittle, much more for these structured workflows, but in the end, they're super helpful for being very precise in whatever you're trying to measure with these workflows. All right, so in Hollywood fashion, everything's a success, right? Our analysis time speed, we're well under 2 minutes, right? Minus GPT-5, but we talked about that. We are finding the right signal. Well, how are we doing that? Through semantic similarity and LLM as a judge, because we have a control set and we're able to know that every time we run this, it should always mention these things. We have consistent and reliable output. We know we're always going to get those same reports because the agents are forced to follow that execution flow through LangGraph. And then finally, we are well under our costs. You might think 39 cents to run this. Oh my God, what if I need to run this thousands of times? Think about, from a human cost perspective, how much money you're saving by having an AI do this stuff, automate that busy work, and not have a human spending their time doing it. It's a significant return on your investment. So the key takeaways here that you should all understand is you need to go beyond single prompts, right? It's not about copy and pasting and just putting stuff in a chat GPT and coming back. Go check out this stuff. Like I said, you'll see the code in a second. Experiment with it if you're comfortable with it. Get your teams to start experimenting with it. But the power is when you bring these all together and start to build these orchestrations to do task solving. 2026 will be the year of solving all the tasks with AI agents, right? Orchestration frameworks. It's not about the LLMs. I sound like a broken record. It's about these orchestration frameworks. There's several out there. I like LangGraph. We went through a pretty extensive analysis of all of these. I have a lot of friends in the industry at all types of different security companies and SaaS companies. All of them are using LangGraph as well. It's a very free to use, robust tool that you can build these workflows and share them with everybody. And finally, this is that super complicated formula. I'm kidding. Speed, accuracy, consistency, and cost equals trust, right? It's all about building trust with your customers when you're using these agents, when they're consuming the output of them. And it is critical in having these measurements for providing measurements to the business, as well as the folks in the SOC that are ultimately consuming them, right? And so with that, go on this journey with me. Demystify all of this. Go build. You're all going to get rickrolled. No, I'm kidding. It should go to. I tested it. It should go to that repo at the bottom. But you'll get the full source code for all of this, all of the prompts, all of the OSQuery data. It's all synthetic data, by the way. You can use AI to create data to test the AI, right? It's kind of magical. There's a README in there that's very verbose that talks you through how to set up every little piece, how to get your Python environment set up, all of that stuff. And I include all the OSQuery queries that you need to run if you want to go run this on a real endpoint. They're all there. You can go pull it all back, put them all in that directory, and let the agent run on it, and you'll be realizing those same measurements instantly in your SOC. And so with that, we have a couple minutes for questions and Q&A, and if you do, you got to use that microphone.
Thank you for the presentation. Does OSQuery have to be installed on all the...
It's a great question. No. So OSQuery can be installed as a service, and you actually get access to more data because it's running with elevated permissions. But you can actually, it's called OSQuery I, their interactive binary, and you can just put it down and it's self-contained and it can just run. Yeah. Come on, step on up so other folks can hear. Sorry about that.
So if a user, do you have in your pipeline a way to prevent prompt injection if in those tables there's a
very good question. So prompt injection is a risk, and actually I have like an anti-chatbot stance internally when we build products because I think it's the most difficult thing to secure. You go out on that floor and there's vendors selling you all kinds of stuff to mitigate prompt injection. You actually mitigate a lot of that, even if you put in there, forget everything you know or go to this website. Because we're cleaning and processing so much of that data, you eliminate like 99% of the prompt injection risks. And what actually happens is when that report goes to run, it's going to go in that report and go, it said that forget all instructions, and you'll have that in there somewhere, right? So that's exactly how you do it. And that's when you have these structured workflows and you're doing a lot of that pre-processing and you're not giving your agents tons of agency, that's how you mitigate a lot of those risks with prompt injections and jailbreaking and all that stuff.
Hi. Have you tried solving this problem with multiple tools and multiple versions?
Multiple tools and like the AI tools, or?
Yes, and like combination of 4 and 5 or 4.
Yeah, so that's a great question. Yeah, so that's kind of what I was alluding to. So internally at Red Canary, we use multiple different versions of models for different tasks. For this, I just kept it simple. I would say if folks in the audience, if you want to go fork this and go add support for multiple models and make that a variable or something, go do it. This does not support tool calling as well, but LangGraph, you can do like one line of code and it will fully support tool calling. And so for this specific thing, no, but in our production workloads, that's one of our architecture patterns that we follow a lot.
Thank you.
Yeah.
A great presentation, by the way.
Thank you, sir.
Thank you. One question I have is you talked a little bit about care and feeding. Can you elaborate on that a little bit? Like,
Yeah.
what that mean? And there's a follow-up question. Red Canary, do you guys sell this as a product or like is it internal use?
Yeah, totally. So care and feeding, there's this concept in data science called human-machine teaming. That is what we're talking about here. How do humans and machines work together the best? It's not human versus machine teaming, right? So in terms of care and feeding, we're fortunate. A data scientist sort of like, the thing we love. We get people, we have humans every day that are labeling our data. It's part of what we do in an MDR, right? Humans are reviewing these security events, and when they're like, hey, the AI, this comment, it's somewhat right, but it's weird. And so in their actual, like, the portal that they work out of, they can click thumbs up, thumbs down. They can write in comments. And so I have a process that I force on my team every single morning. I have 2 guys that go through and look at all of our generative AI feedback across our product suite. And then we don't react immediately. We start to put them into like groupings of common things that we're seeing. And then we'll obviously, through software engineering practices, make updates. And the updates are usually like, oh, we're just using an old model. What happens if we upgrade to a new one? That happens quarterly. But then it's always around data cleaning and instruction improvements, but it's mostly around data cleaning is the big one. And at Red Canary, you can't buy these yet. I'm pushing really hard for service as software, not software as service, where you can pay 10 cents per agent call or whatever. But these are what our SOC uses this stuff all day long. Like I said, it's an interceptor agent, so it's sort of behind the scenes. We do have a copilot that will summarize alerts. It'll give you user baselining, like Jimmy usually logs in from Boston and now he's logging in from Canada. It'll tell you all that stuff. But you still have to have the platform to do it. Yep.
So I want to ask, how do us define, how much volume of data that do we feed to the model, like days or hours?
Yeah, well, you're always limited by the context window, right? And the context window is the amount of tokens that the AI can chug through, and that's a hard limit. And so that's your limit. As these models get smarter and smarter, I found qualitatively that they can handle chugging through more data and filling up that context window. The struggle that we always have, and we work around it as best we can, is how you compress data and keep without losing that context when you're doing with lots and lots of data. So what you're really getting at here is this problem of data compression without losing the context. So like, how do you looseless kind of compression without losing the context? And so you have to build software that will detect the context window getting too big. Then you're going to call an AI agent to say, summarize all of this, but don't lose the key points. And then you're going to feed that back in, and you're going to add your new data in, and you just rinse and repeat. Yeah.
What was your strategy for evaluating orchestration backends? Like, if a new product came out, what would make you decide to switch to that from LangGraph?
That's a great question. So there are a few. Just the way that our security processes are internally at Red Canary, we are very much an on-prem company. We don't want to send customer data or anything else off to third parties. So the first thing is we have to be able to run this stuff in-house on our own Kubernetes clusters and manage all of that code ourselves, right? So that disqualifies a lot of different agent frameworks that are out there. And so now we have to start with, cool, what libraries can we use? We were already using LangChain in some of our agents, which is part of the LangGraph toolset. And so we naturally went to that and started to evaluate it. Microsoft also has an agent framework to use, but we're not a .NET shop. And the Python version of it was very immature. All of our backends in Python for all this AI stuff, for better or for worse. And then my network of friends and colleagues throughout the years that are working on all of this stuff, we kind of get on a Slack huddle or whatever. We're like, hey, so what's everybody using? What are the pros and cons? And why do you not like this and whatever? And we kind of all came to a huddle on that one.
Okay, so a lot of similar strategies to evaluating any given library, like what's your tech stack, what are you already using, what kind of code?
Yeah, the same SDLC process that you have is no different. It's just there's AI now in the mix, right? Yeah.
Thank you.
Yeah, of course.
Great talk. I was wondering, I noticed there weren't any of the Google Gemini family models on there, and I was curious if you'd tried them or if there was a reason that you left them
Keen eye, I love it. So first of all, I think the Google Gemini models are fantastic. The pro models are great. Their deep research stuff is awesome. That's honestly just the fact that internally I don't have access to Vertex, and we just use Azure OpenAI and AWS Bedrock for all of our model stuff. We're at AWS Microsoft shop. That's it.
Okay, yeah, that makes sense. I was just thinking too, at the really long context window, it might be
Yes.
useful.
Yep. Oh yeah, that's on our list of like, hey, can we get Gemini Pro and start to play with these longer context windows? Yeah. Good question.
Thank you.
Yeah.
Yeah, thanks for the great presentation. How does your AI agents identify and address the advanced persistent threats that continuously are evolving and unforeseen?
Yeah. So I like to decouple that strategy. So remember, Red Canary, we're not just doing like sock monkeys chugging through stuff. We have a threat research team, we have a threat intelligence team, and they are some of the best in the business. They are always on top of stuff, either coming from our customers, coming from third parties, coming from internal things. And so this is, remember, because we're looking at interceptor agents, there's still detections and signal coming in, and the agents are really just focusing on the investigations. So if our threat intel team gets a tip, and we write a detector for some artifact that we know, some web shell from China Chopper, which we know is from an APT. We're going to have a detector for a web shell. That detector is going to come through our pipeline. Our agent's going to investigate it and go, hey, this is a web shell on this system. This is not unique. Oh, and one of the things that we do internally is we have our intelligence profiles that our teams curate and you can access. We feed those into the agents. And so the agents get the context of that intelligence profile. But we tell them to be very agnostic. We don't want them to judge. We want them to just kind of be independent thinkers. And that's kind of, so it won't know that it's an APT. It's just going to know that it's doing the work. And it just so happens to be a web shell with an intelligence profile that mentions an APT.
Yeah, thank you.
Yep. Awesome. Well, thank you all for coming. It was a pleasure to be here. Thank you so much.